Welcome to Simply H2 Math video series specially made for JC students. I'm Mr. Song from Learning Simplicity.
Welcome to the first part of two video series of functions. For this topic of function, first of all, let's discuss about the existence of a function, or what defines a function. So for the first graph, I've drawn a graph of y equals to x. For the second graph, I've drawn the graph of y equals to x squared. And this is a parabola. Next up, we have another parabola, y squared equals to x. The last graph that I've drawn is the graph of a circle. The equation is given to be x squared plus y squared equals to 1. So what does that exactly define a function? So we realize that for the first graph, let's explore this further. For a x value, a particular x value, you have a y value. For the second graph of y equals to x squared, for two x value, they share the same y value. So x1 and x2 share the same y value of y. So for the next graph, y squared equals to x, for one particular x value, you have two corresponding y values. For the last graph of the circle, for a particular x value, you have two y values. In addition, for two x value, they also share the same y value, which I've not illustrated on the graph. So to explore further, for the first line, y equals to x, this is a one-to-one function. For the second graph, this is a many-to-one functions. So you can see from here that for function, for every x value, you must have one y value. For the third graph that you have, this is not a function, this is a relation. Because for one x value, you have many y values. So the last one is also not a function, it's called a relation. It is a many-to-many relation. So once you are clear about how to define a function, now let's move on to define a function properly. To define a function, we always take note that we have to define the rule, which is the equation of a function, as well as the domain of the function. So to discuss further, let's supposedly we take an example of f(x) equals square root x. The domain of a function is a set of all x values. So in the example given, I've given the domain of f to be x bigger than or equal to 0. Correspondingly, to find the range of the function, we can look at the output. And this output is a set of y values. To determine the y values, we have to draw the graph of the function of f(x). You can take note that for the given domain of x bigger than or equal to 0, the corresponding y values, or the output, is given to be 0 to infinity, where 0 is inclusive. So this is how we can write down the range of f. It's a set of values whereby y is bigger than or equal to 0. Next up, we are also interested to find out the inverse of a function. Inverse of a function is defined to be f inverse x. So how do we get an inverse function? When do inverse function exist? For a function given to be a function given, we can always try to use a horizontal line test. The example will be, supposedly we have a f(x) equals to a function of 2x plus 1. Given the domain of all real numbers, if you use a graph to determine the graph of 2x plus 1, you realize that for every horizontal line y equals to k, where k belongs to the range of f, it cuts the graph of f(x) exactly once. So it means that f is 1 to 1, and therefore f inverse will exist. So existence of inverse function will be the case whereby f is 1 to 1. To sketch an inverse function, note that f inverse is not the same as reciprocal graph, it's not the same as 1 over fx, it's also not the same as f prime x. So given a graph of fx, to find out its inverse function, we can always reflect about the line y equals to x. So the resultant graph is the graph in red, which you can see on the function, the graph. So take note also that for the function of f and f inverse, they intersect at a point, at 2 points. And these 2 points are also intersection of the line y equals x and fx, as well as y equals x and f inverse x. How about the equation of f inverse x? How do we exactly define f inverse x? Note that because x of fx is now the y of f inverse and vice versa, we can always try to define your f inverse x in this manner. For a function of 2x plus 1, where x belongs to a real number, I can always let y to be 2x plus 1 and make x the subject, which will be y minus 1 over 2. So f inverse x will be x minus 1 over 2. How about the domain of f inverse? It's the same as the range of f. And once you draw out the graph of fx, the range will be all real numbers. That's the end of the first part of 2-part video series on functions.